All right, let's consider this chemistry question. So if you look at this diagram, we have a flask, which is a conical flask, and inside it we have a test tube that is suspended by means of a string containing solution X, and then the conical flask itself originally contains a solution Y. So let's read what question is underneath the diagram. An experiment test of the law of conservation of mass is illustrated in the diagram. In practice, the flask is weighed before and after reaction between solutions X and Y. Which of the following pairs of solution will be unsuitable for the experiment? So very good. You need to consider certain concepts here. First, the law of conservation of mass. Law of conservation of mass. So the law of conservation of mass says that energy is neither created nor destroyed. Matter is neither created nor destroyed. So matter is neither created nor destroyed. What this is saying is that the total mass before reaction must also be equal to the total mass after reaction. That is, the total mass of the reactant must be equal to the total mass of the product in any chemical reaction or in any chemical experiment. So, looking at that, this is the facts that we should have in our mind before selecting our option. We'll look at the option in which, when we perform the reaction, so there will be no loss of mass in form of anything, whether in form of gas or in form of solid or in form of liquid, or in form of heat. So if there is nothing like that, then that will be the best answer to the question. Let's consider option A first, hydrochloric acid and AgNO3. So this will give us triazonitrate 5 acid, that's the nitric acid, and then silver nitrate will be formed. The silver nitrate is soluble in water. So everything will still remain in the solution. Everything will still remain in the silver chloride. Everything will still remain. So that means there is entirely no loss of mass. Consider this is barium chloride and dilute H2SO4. This combination too will not lead to any loss of mass, because this will produce barium sulfate and hydrochloric acid. So let's go to the next one, which is hydrochloric acid reacting with what? Sodium hydroxide. This is neutralization reaction, which will lead to the formation of salt and water. This is also not a problem. Let's go to the next one, hydrochloric acid plus lead nitrate. This will lead to HNO3 formation and then lead chloride too, which is also not going to be lost. Then we go to E, HCl plus Na2CO3. This is where the problem is. Now, this will lead to the formation of sodium chloride first. Then we are going to have water, which is H2O, and finally we have CO2 being liberated. So the CO2 will lead to what we call effervescence, which is bubbling. And this effervescence means that the gas will be released. So it means a part of the system is lost to the surroundings. So in that regard, the best answer to this is option E. So that means this combination is not suitable to prove this law, that is law of conservation of mass. Thank you.